Okay, so section 2.6 is limits at infinity.
Professor?
Yeah.
Quizzes and exams are on WebAssign, right?
The test will be WebAssign. This quiz will be in Canvas.
Okay, thank you.
So we're going to start with an example. There's this function f right here. Horizontal asymptote at y equals 0. Okay, we're going to write that the limit as x goes to infinity of f of x equals 0. So as your x values go to positive infinity, f of x values go towards an output of 0. Let's do the limit as x goes to negative infinity of f of x. Okay. So this time x is going this way, but your outputs are also going towards 0. All right, this graph will be called g of x. We have horizontal asymptote at y equals 5. And then we're going to go up and then swivel around that asymptote. Let's go towards positive infinity first. So as x goes to positive infinity, g of x of this function, g. Okay, this time your outputs are going to a limit of 5. As g of x, the limit as x goes to negative infinity, let's do that first. You're going off into an limit of negative infinity. Let's do this sine of x. So just y equals sine of x. Okay. Where sine start at the origin, and then we go up to up to 1, down to negative 1, up to 1, down to negative 1. Same this way, oscillate that way. Complete one cycle at 2 pi. One, call this 1 each. -1. That's good enough. Oof, man, my sketch looks pretty shaky, but it's, it's the right idea. Okay, limit as x goes to positive infinity, sine of x does not exist. Same as you go to negative infinity, the function oscillates and you don't reach any value. The limit does not exist.
Could you explain again one more time?
Yeah. Well, I'm gonna write down since the function oscillates. So if you try to pick a value for the limit, how would we do the proof? I'll just try to explain again. So as the function keeps going, as x values keep going towards positive infinity, the outputs keep changing from -1 to +1 and -1 to +1, and you don't reach any number as a limit. And the function doesn't like grow without bound or decrease without bound. So it's not a limit of negative infinity or positive infinity. So the limit does not exist. Another example. Let me find this example we talked about before. This one function from the book. I don't want to grab the book. Okay, I'll be back. Well, this is an interesting function. We should talk about it. Okay, let's find this. Well, I'm going to stay on track with my notes actually, and we'll just write down this definition of what these infinite limits are, and then I'll try to maybe find that example that I'm thinking about. But moving on. Definition. infinity f of x. Equal to. As x grows without bound towards positive infinity, f of x gets arbitrarily close to some value L. As x, just grows without bound. Okay, write down the other definition, and then I think I know where I can find a good explanation of that last example I had. So the other one is for x going to negative infinity. So as x decreases without bound to negative infinity, f of x gets arbitrarily close to L. Okay, so let's see if I could quick search this, but we don't want it to do too much time. Windows. All right, the big binder. Okay, I was hoping to find like a proof. I might peek for just one more second to like kind of quickly describe the limit for sine of x. And I did find that function that I was interested in, but it's kind of not the same. See if I can get this. I can't find it. Let's see if we could talk through it. So back to, let's like draw cosine this time. So back to some trig function that oscillates. Okay, Here. We're gonna go cosine down, I'm gonna check again my definition. Infinite limits. Oh, okay. Actually, we talked about this kind of infinite limit. Okay, I'm gonna give up searching. Back to what we wrote down. So it's the limit as x goes to infinity of f of x equals L. I'm missing something like the precise definition or something like that from this. I will put this as a side note. It is important. Whoa, yikes. Sorry to startle everyone. So this is important. I've done proofs on this before. I'm just not finding it and it's not coming to mind. Of like, we want to know if we can put some kind of bound here. And as x keeps changing, the values of the function are going to leave that bound. So there's some kind of epsilon greater than 0, such that when like you've got an epsilon neighborhood here, the function would stay within that neighborhood, but that doesn't happen in this case. It keeps on leaving and coming back and leaving and coming back. All right, so we're gonna get back to my like scheduled notes and I'll do this one next time. Thank you for asking. Sorry if I kind of like wasted class time. Okay, horizontal asymptotes. That's what was next. Okay, it's kind of same idea. So y equal to L is a horizontal asymptote. If limit x goes to infinity of f of x equals L. Or if you have x going to negative infinity of f of x equal to L. Cool. I have examples. Where are we at? Okay. Let's do the limit. Okay, so the limit as x goes to infinity of, in the numerator, it's 2x to the fifth minus 3x to the fourth plus x squared minus 8. My denominator is 3x to the fifth plus 7x minus 1. And we just find the limit. All right, so one of our tricks is to find the highest power of x and divide through by that value, so x to the fifth. We'll do limit as x goes to infinity, 2x to the fifth over x to the fifth minus 3x to the fourth over x power 5. Another one. X to the fifth, and this last guy. Same thing to the denominator, 3x to the fifth over x to the fifth. Plus 7x over x to the fifth. Last one. All right, reduce all of these fractions. Oof, it's so hard to draw this. All right, so 2 minus 3 over x plus 1 over, what's this, x cubed? Make sure I've got this. Minus 8 over x to the fifth. All right, in this denominator, 3 plus 7 over x to the fourth. Subtract 1 over x to the fifth. Okay, we'll get the rest of the problem up in a second. But what happens is, as x goes into infinity, as x is some very, very large number in this denominator, a number over big equals small. So this is going to 0. And I'll write this down after we do the problem. This goes to 0. 1 over big is small. That's a 0. That's a 0. These are all 0 for the limit. This one to very, very small number, which is basically 0. Okay. So the limit as x goes to infinity of that function we had will equal 2/3. I'm just going to write this equals. Okay. I've got, for a rational number r, we'll put number, it's fine. the limit as x goes to infinity of 1 over x to the r will equal 0. Same for x going to, let's see, if it goes to negative infinity, is there a difference? R is a rational number. Oh, actually, this doesn't need to be the number 1. It can be some k, where k is a constant. Let's see what happens if you go to negative infinity. You also get 0. Hopefully, let's see. This will fit. Cool. Back to examples. So the limit as x goes to infinity, get the function in a second. Function is 5x squared plus x minus 1 over 3x cubed plus 7. All right, the highest power of x will be this x cubed. So we'll divide through by x cubed. 5x squared over x over x cubed and over. All right, 3x cubed over x cubed plus 7 over x cubed. All right, let's reduce some stuff. I want to just go. So we'll have 5 over x. Let's see, plus 1 over x squared. And then subtract 1 over x cubed. All right, 3 plus 7 over x cubed. Clear? Yeah. Let's go with that's going to 0. This has a limit 0. This has a limit 0. We've got 0 in the numerator. This is also going to 0. Let's see. 0, 0, 0. And this is a 3. So, but you still get 0. I have another note. by the way, that function has a horizontal asymptote at y equals 0. Forget this one. So I put this down and I hope I checked it, like Googled it, but I hope it makes sense. So we have the absolute value function we talked about before. You have x if x is greater than or equal to 0. And then negative of x if x is less than 0. So my note or kind of hint is to use this, the square root of x squared if x is greater than or equal to 0, and the negative of the square root of x squared when x is less than 0. Okay. I'll show you why. Next example, we do another limit as x goes to infinity. In the numerator, there's the root of 1 plus 4x squared. And it's over 4 plus x. Okay, we're going to divide through by the highest power in x, which is x. So it's this root of 1 plus 4x squared over x. And then we put 4 over x and x over x. That's my denominator. I will replace this x, and it's a positive x because we're going to positive infinity. So we're going to put in root of x squared instead of x. No, it doesn't use my phone. Okay, this denominator is 4 over x plus 1. Square root over square root, we can bring the root in, it's a square root divided by a square root. So under that root is 1 plus 4x squared over x squared. Over x squared plus 4x squared over x squared. And that denominator is still there. Okay, the root of 1 over x squared plus 4. over x squared. Over 4 over x plus 1. So let's put in this kind of infinity. So this will go to 0. Same here, this goes to 0. Root 4 is in the top, and there's 1 left over in the denominator. Plus 2. Okay, so we're just taking that same function and going to negative infinity. Similar steps, so we're going to jump through some parts of the problem, but not too fast. So it was the root of 1 plus 4x squared over 4 plus x. Did I make a mistake in the, no, yeah, that went to 0 and we got a 1 and we're okay. Yes. Do the same kind of thing, but this time when we divide by the x, so we got limit x goes to negative infinity, root of 1 plus 4x squared over x over 4 over x, x plus x over x. These x values are going to negative infinity, and this x we're going to replace with the negative of the square root of x squared. Okay, what's here? This is 4 over x plus 1. So this negative sign, I'm going to write here. And then under the square root is 1 over x squared plus 4x squared over x squared. So let's take care of that. X goes to negative infinity. Take care of the negative sign. There's a root. There's 1 over x squared plus 4 over 4 over x plus 1. Okay. This is 0. This is 0. As you do the limit, it's negative root 4 over 1. This time it's negative 2 instead. Where are we? Okay, we've got 4 minutes. Let's do an easy one. So we're going to have the limit as x goes to infinity of 2x squared minus 1 over x plus 5. So the highest power of x will be x squared. Let's divide through by that. Is That's the numerator. There's the denominator. So just simplify the fractions. You got limit as x goes to infinity of 2 minus 1 over x squared over 1 over x plus, oops, okay, well, let's say 5 over x squared. This is still okay. So what happens, oh, I messed something up here. I think that I didn't do it this way the time before. Let's see what happens if we can talk about this. So what's going on if I do it this way? This would be a 0 plus 0. We have something over 0, which is not okay. So I don't think I want to continue doing the problem like this. Because I would get like 2 over 0. And that's not the answer. Infinity. Yeah, the answer is infinity. So I'm going to back up and show you how I did it the first time on my scratch paper so we can end the class. So let's divide by just x. Also, thanks for the answer in the chat. 2x squared over x minus 1 over x over x over x and 5 over x. Limit as x goes to infinity. There's 2x minus 1 over x is over 1 plus 5 over x. Okay. This way, this goes to 0, this goes to 0. Now my denominator is 1. And the 2 times infinity has my limit going off to infinity. So let's do, that was 0, that was 0. Don't forget about 1 here. My answer is infinity. Where I put this little part too. Okay, let's end there. And thanks everyone. Have a good day.